Okay, listen dear students. 21st question, how to solve. Now, cell constant we need to calculate for 21 question. This question, cell constant. We know what is the relation or formula for this question. The important formula for this question is specific conductance. K is equal to conductance into cell constant. Okay. And K is equals to conductance is nothing but 1 by R into cell constant. So what they are asked in this question, cell constant they are asked. So the cell constant is nothing but L by A is equals to K into R. K is nothing but specific conductance or conductivity. Specific conductance or conductivity, how much they gave? 2.768 into 10 to the power of minus 3 into R value. Resistance, how much they gave? 82.4. 82.4 they gave. This is on simplification. We'll get 0.2281. 0.2281 centimeter inverse. Okay. See in this question, specific conductance K value they give. Okay. And R resistance R value they gave. They are asking what is the cell constant of the cell when the cell is made up of by 0.02 molar KCl, potassium chloride solution is present. So here don't worry about that concentration. So what we need to find out, cell constant we need to find out. For this relation formula is K is equals to 1 by R into cell constant. Then cell constant is equals to K into R. Okay. Next, let's see 22nd question. How to solve this 22nd question? Equivalent conductance. Equivalent conductance they gave 91.0 ohm inverse centimeter square equivalent inverse. Okay, it's very clear. Now its conductivity or conductance, specific conductance K value we need to calculate. For this case, what is the formula? The equivalent conductance is equals to K into 1000 by normality. So here normality of copper sulfate. Normality of copper sulfate is equals to weight by gram equivalent weight into 1000 by volume of solution V in ml, and the volume is there mentioned, it's very clear, per liter 2.54 grams of copper sulfate is present in 1 liter solution. So the gram equivalent weight of copper sulfate is equals to gram molecular weight by n factor. Copper is in +2 state and sulfate is -2. That's its n factor is equal to 2. 2.54 by gram molecular weight of copper sulfate is 160. Means copper is 64, sulfur 32, 4 oxygen atoms, each oxygen atom 16. 16 for the 64. 64 plus 64 plus 32, then we'll get 160. Okay. So 160 by 2 into 1000 by 1000 ml. Then this is on simplification, we'll get normality is equals to 0.03175 normality will comes. Now the K is equals to pi into normality by 1000. Okay, pi value is 91 and normality is 0.03175 by 1000. This is on simplification, we'll get this multiplication of 91 into 0.03175 is nothing but 2.0 2.889 into 10 to the power of minus 3. 2.889 is nothing but approximately we can write as 2.9 into 10 to the power of minus 3 ohm inverse centimeter inverse, ohm inverse centimeter inverse. So the answer is the correct answer is 2.9 into 10 to the power of minus 3. Fourth option is correct. Okay, students. Let's see 23rd question. 23rd question. One graphical representation they gave. Among that we have to identify x, y and z. 23rd. Okay, it's very clear. Strong electrolytes. Equivalent conductance are molar conductance with respect to concentration. Okay, so equivalent conductance or molar conductance, concentration increases, their conductivity will be decreases, and it is a straight line for strong electrolytes. Strong electrolyte. So strong electrolyte is nothing but, what are the strong electrolytes? Strong electrolytes is nothing but strong acid, strong base, and strong acid plus strong base salts. See here, the strong acid among that, strong acid salt among this KCl, potassium chloride. Let's see in the same way, the equivalent conductance or molar conductance with respect to concentration for weak electrolytes. For weak electrolytes, it will comes a curve. Slowly it will be comes like a curve. So for this case, among that weak electrolytes are nothing but weak acids and weak bases, and weak acid, weak base salts. So among these weak acid is acetic acid they get, CH3COH. Now observe that, so in a graph, one is strong electrolyte, it is straight line, gradually decreases. The second one is it is a medium, is not a completely weak electrolyte. The third one is completely weak electrolyte. The weak electrolyte means it is acetic acid, CH3COOH. Strong electrolyte means KCl. So let it is X and it is Z. X is equal to KCl and Z is equal to acetic acid. So like option is present on second, then obviously the middle one is nickel sulfate, NiSO4. That is why. Okay, so the answer is the strong electrolyte is potassium chloride, and intermediate is nickel sulfate, and very weak electrolyte is acetic acid. Their molar conductance with respect to concentration graph is a straight line for strong electrolytes and a curve for weak electrolytes. So the answer is second option. The answer is a second option. Okay, let's go for next question. 24th. 24th question. The resistance of 0.5 normal solution of an electrolyte in a conductivity cell was found to be, 45 ohms. Means the R value, R is equal to how much they gave, dear students? 45 ohms. The resistance of conductivity cell. If the electrodes in the cells are 2.2 centimeters apart from the area, means area is equals to 3.8 centimeters square. Then the equivalent conductance they are asked. Okay, so cell constant L is equals to 2.2 centimeters, and area of cross section is equals to 3.8 centimeters square, 3.8 centimeters square. Okay, then what we have to find out in this question, we have to find out the equivalent conductance. Equivalent conductance we need to calculate. And we know that equivalent conductance formula is equals to K into 1000 by normality. So for this K we have to find out, and K is equals to 1 by R into L by A. 1 by R into L by A. 1 by R is nothing but 1 by R is nothing but what? Conductivity or conductance of the cell, and L by A is nothing but cell constant. So 1 by 45 into L by A. L length is 2.2 and area of cross section is 3.8. This is on simplification. We'll get K value is approximately 0.01286. 0.01286. Okay, now pi is equals to pi equivalent conductance is equals to K is nothing but 0.01286 into 1000 by normality of the given electrolyte is 0.5 normal divided by 0.5. This is on simplification. We will get 25.72 Siemens centimeter square equivalence inverse. S is nothing but ohm inverse. Okay, let's see the 25th question. So 24th one is first option is correct. Now 25th, the ionic mobility of cation and anion. Okay, cation and anion ionic mobility values they gave 140 and 80 ohm inverse centimeter square equivalents respectively. The equivalent conductance at infinite dilution, the equivalent conductance they asked. So the ionic mobility is nothing but ionic conductance of cation and anion. Cation is equals to 140 and the ionic conductance of anion is equals to 80. Now the equivalent conductance at infinite dilution is equals to ionic mobility of cation and anion. Sum of the cation and anion is equals to 140 plus 80 is equals to 220. 220. So the answer is second option. Okay. Let's go for next question. 26th one. Among the following, which is correct representation of law of independent of migration of ions? Law of independent of migration of ions means what, ma? Kohlrausch law. Kohlrausch law. Kohlrausch law. Okay. So the Kohlrausch law is nothing but what, my dear students? The at infinite dilution, the molar conductance is equals to sum of the molar conductance. Here, V positive ions are present, sum of the molar conductance of cations plus sum of the molar conductance of anions. So according to that, we can choose third option is correct representation of molar conductance at infinite dilution based on Kohlrausch law. Based on Kohlrausch law. Okay. Let's go for 27th question. The ionic conductance at infinite dilution of Ag plus ions they gave, and the ionic mobility of Ag plus ion there are silver ions. So we know that relation, the ionic mobility of cations as well as anions. The ionic mobility of cations here mole inverse meter inverse SI units they gave. That's why we have to divide it by 96,500 coulombs. So the ionic mobility of cation Nu plus here silver ion is there, Ag plus is equals to ionic conductance of silver ion Ag plus by 96,500, then uh, it is 61.92 into 10 to the power of minus 4 by 96,500. Then we'll get the answer is, on simplification we'll get 6.41 into 10 to the power of minus 8. 6.41 into 10 to the power of minus 8. So the answer is first one is correct. Answer is first one is correct. Okay, see here ionic mobility of cation is equals to ionic conductance of cation at infinite dilution by 96,500. The same way anion do you want means ionic conductance of anion at infinite dilution by 96,500. Then we are getting ionic mobilities of cation as well as anion will get. Okay, let's go for next question. The specific conductance of saturated solution of silver chloride they gave K value. The specific conductance is K, then the limiting ionic conductance of Ag plus and Cl minus ions are respectively X and Y they gave. The solubility of AgCl in gram per liter they are asked. Okay. So what is the solubility we need to find out. So for this case, the limiting, we know that solubility the limiting molar conductance is equals to K into 1000 by molarity. Okay, if molarity is nothing but solubility of silver chloride AgCl. Okay, then and the limiting molar conductance is equals to the molar conductance of Ag plus ions plus the molar conductance of chloride ions at infinite dilution is nothing but X plus Y. Okay, now K is nothing but specific conductance, then X plus Y is equals to K into 1000 by solubility, then S is equals to K into 1000 by X plus Y. What are the units for this? Mole per liter, mole per liter, and 1 mole of AgCl is equals to 143.5 grams. Therefore, the solubility in terms of gram per liter, in that mole place we have to write 143.5 grams. K into 1000 by X plus Y into 143.5 gram per liter. Okay, so this is the solubility expression in terms of molar conductance as well as a specific conductance. So molarity is nothing but solubility of a solute present in the given solution is nothing but molarity. So in terms of a equivalent conductance as well as a molar conductance and its specific conductance. This is the relation between the solubility and the molar conductance and specific conductance. S is equal to K into 1000 into 143.5 by X plus Y or molar conductance of silver chloride in gram per liter, in gram per liters. Okay, students. Okay, let's go for next question. 29. 29th question, at 25 degrees centigrade, the ionic mobilities of acetate ion and H plus ions they gave. Now the conductivity of 0.01 molar acetic acid is K value they gave 5 into 10 to the power of minus 5. The dissociation constant we need to find out. So acetic acid is a weak acid. Acetic acid is weak acid. Its dissociation constant. Constant Ka is equals to C into alpha square. Okay, alpha is equals to degree of dissociation. Dissociation alpha is equals to degree of dissociation. Okay, that alpha is equals to degree of dissociation is equals to the molar conductance at given concentration. Molar conductance at given concentration by molar conductance at infinite dilution. Molar conductance at infinite dilution. At infinite dilution. Okay. Now the molar conductance at given concentration they gave how much? 5 into 10 to the power of minus 5, and the molar conductance at infinite dilution of acetic acid is equals to the sum of the molar conductance of acetate ion and H plus ions, that is 4.1 into 10 to the power of minus 4 plus 3.63 into 10 to the power of minus 3 is nothing but on addition, then it is equal to 4.04 into 10 to the power of minus 3, 10 to the power of minus 3, and molar conductance at given concentration is equals to 5 into 10 to the power of minus 5. Therefore, alpha is equals to 5 into 10 to the power of minus 5 by 4.04 into 10 to the power of minus 3 is equal to, this is on simplification, we will get approximately 1.24 into 10 to the power of minus 2. That is alpha value or degree of dissociation constant. Then Ka is equals to C alpha square. Ka is equals to C alpha square. Then concentration is of acetic acid is 0.01 into 1.24 into 10 to the power of minus 2 whole square. This is on simplification. We will get 1.53 into 10 to the power of minus 6. 1.53 into 10 to the power of minus 6. Actually, here options are not clear. See, this option is belongs to 1.56 or 53 into 10 to the power of minus 6 is correct. Okay. Let's go for next electrochemical series and EMF calculations related problems. Now, the first question, let's see the 30th question. Hydrogen electrode. We know very well hydrogen electrode. Electrode is reference electrode. We are using as reference electrode. Okay. See, hydrogen electrode acts as anode. For example, acts as anode. At anode, what happens? Oxidation will take place. Oxidation means H2 gas of H2 is converted into H plus ions concentration. H plus loss of one electron. Okay. Now, according to E cell, it's E0 cell, hydrogen electrode E cell. E0 cell is equals to 0.0 volts. It's very clear. Now, EMF of the cell or E cell is equals to E0 cell minus 0.059 into log concentration of products by concentration of reactant. Concentration of product is nothing but H plus ions concentration by 1. So E0 cell is 0, then E cell is equals to minus log H plus ions concentration is equals to nothing but pH. So is nothing but 0.059 into pH. So when it acts as a anode, its E cell is equals to 0.059 into pH. When it acts as a cathode, so what happens? Reduction will take place. H plus ions accepting one electron to forms of H2 gas. For hydrogen gas, their active mass is equal to 1. Now E cell is equals to uh, 0 minus E0 cell is 0 minus 0.059 by 1 into log concentration of 1 by H plus ions. This is nothing but minus 0.059 into minus log H plus ions concentration is equals to pH into pH. Okay, if it is acts as a cathode. Now options, let's see. It is depends on nature of metal electrodes. Okay, so the hydrogen electrode pH value or electromotive force, the electrode potential, its electrode potential is EMF depends on nature of electrode and its pH value. Nature of electrode and pH. Here nature of electrode means, especially here C it is negative sign, means E cell, the hydrogen electrode value mainly depends on, the first option is only pH of the solution, both the metal electrodes used as anode. So both nature of metal used as anode and pH only is used, not both the metal electrodes. The nature of metal electrode used as cathode and its pH, because the pH, the resultant E cell is positive. The nature of electrode, that is cathode only. Okay, let's see. EMF of the cell is depends on nature of cathode and its pH value, not both. Okay, it depends on any one of the electrode. So its pH, because it's if it is acts as a anode, it acts as a anode, its pH value is 0.059 into pH. So however it is depends on pH value, and the if hydrogen electrode is a reference electrode, it acts as a anode. It acts as a anode means the remaining cathode. If the resultant pH value or electromotive force of the cell, EMF of the cell, EMF of cell is depends on nature of cathode and pH value, because if it acts as an anode, the electromotive force of the cell is positive. If it is came positive, okay, 0.059 to pH. So however it depends on pH, and when it becomes a positive value will comes. So the resultant depends on EMF the cell is equals to cathode, the standard reduction potentials of cathode minus anode, standard reduction potential of anode. So the EMF of the cell is depends on the nature of metal used as cathode and its pH of the solution So the answer is both option is correct. Okay, let's see that 31 question, among the following reaction which is spontaneous? Spontaneous reactions. Spontaneous means E cell or E0 cell is equals to positive. Then only the reaction is spontaneous. Okay. Now let's see the standard reduction potential values. E0 means standard reduction potential value of Zn plus 2 by Zn is equals to 0.76 volts. Next, E0 of copper plus 2 by copper is equals to copper plus 2 by copper is equals to 0. Zinc is -1. Zn2 plus by Zn is equals to minus 0.76 volts. Then E0 of copper plus 2 by copper, standard reduction potential of copper is equals to 0.34 volts, 0.34 volts, and E0 of silver Ag plus by Ag is equals to 0.8 volts. Okay, and hydrogen electrode E0 of H plus by H2 is 0.0 volts. Now we have to find out that first one, Zn plus 2H plus is converted into Zn plus 2 plus H2. It is a reduction. Reduction means cathode, and it is anode. Zn zinc acts as a anode because it oxidation takes place. Then E cell is equals to E0 cell of cathode minus E0 cell of anode. Then it is 0 minus of minus 0.76 is nothing but plus 0.76 volts. So the reaction is spontaneous. If E cell is positive, then the reaction is spontaneous. Non-spontaneous reactions we need to identify. Let's see, the second one is copper undergoes oxidation, then E cell is equals to E0 cell of cathode minus E0 cell of anode. E0 cell of anode. Cathode, see in the given second equation, it acts as anode and hydrogen electrode acts as a cathode. Now, its value, hydrogen electrode is 0 and copper is 0.34. 0.34 volts. The resultant value is minus 0.34 volts. So the E cell is equals to negative. If E cell is negative and the delta G is positive, E cell is negative and delta G is equals to positive, then it is non-spontaneous. Non-spontaneous process or non-spontaneous reaction. So the answer is second option is correct. Non-spontaneous we have to identify. The third one, let's see, zinc is anode, copper is cathode. So in the third one, E cell is equals to cathode is copper, means 0.34 minus of minus 0.76 is equal to 1.1 volts. Okay, 0.34, 1.1 volts is nothing but what? Galvanic cell. The third one is nothing but standard galvanic cell. The E0 cell is equals to 1.1 volts. So it is also spontaneous. The third one is also spontaneous. Let's see the fourth one. in this copper undergoes oxidation. That's why copper is anode, the silver is cathode. Then the E cell is equals to 0.8 minus 0.34 is nothing but 0.46 volts. It is also positive. If the E cell is positive values, then it is spontaneous. If it is not negative, non-spontaneous. So the answer is second one is correct. Second one is correct. Okay, let's see 32. 32 question. See, for a cell reaction, magnesium Mg solid plus copper 2 plus aqueous is converted into copper solid plus Mg plus 2 aqueous. See, magnesium is undergoes oxidation and copper is undergoes reduction. So the magnesium is undergoes oxidation means it acts as anode, and the copper is undergoes reduction means it acts as a cathode. Okay, now the standard reduction potentials of magnesium and copper they gave. Now what is the EMF of the cell? The EMF of the cell, E0 cell is equals to E0 of cathode minus E0 of anode. E0 of anode. So here in the cathode is E0 of copper plus 2 by copper minus E0 of anode is magnesium. Then its standard reduction potential is Mg plus 2 by Mg. They gave that is magnesium is minus 2.37, copper is plus 0.34. 0.34 minus of minus 2.37 is nothing but 0.34 plus 2.37. Then both you have to add, then 2.71 volts. 2.71 volts plus, it is having plus sign. See, this kind of equations they gave means first we have to identify which acts as a cathode and which acts as a anode. So in the above reaction, copper acts as a cathode and magnesium acts as a anode. So the given reactions, reduction potential, electrode potential, both are reduction potentials only they gave. If both reduction potentials they gave, that's a case the E cell or EMF of the cell is equal to E0 of cathode minus E0 of anode. Okay, both reduction potentials they gave. If both oxidation potentials they gave means E0, E cell is equals to, do you want E cell means E0 of anode minus cathode. E0 of anode minus cathode. One is oxidation potential, another one is reduction potential they gave means the E cell is equals to E0 cell of anode plus E0 cell of cathode. Okay, so these are the different types of formulas to find out the E0 cell of a reaction. So both standard reduction potentials they given means the E cell is equals to E0 cell is equals to E cell of cathode minus E0 cell of anode. Okay. Okay, students, the remaining we will discuss in the next class.